Last presenter for this session is Natasha Butler with Colorado DOT, and this is on their preservation and asset management program.
All right, so I've got a kind of a three-part presentation put together here, but as Travis mentioned, I'm gonna hit probably the first two parts, and then if anyone has questions, we can talk about the other part later. Preservation and asset management at Colorado. I heard a good term today, so I'm going to use it again, CDOT by the numbers, right? For this presentation, I'm really focusing on those structures that qualify for the National Bridge Inventory, so with spans over 20 foot. We do inspect our smaller structures as well, but I'm going to focus on these larger ones for this presentation. CDOT owns around 3,500 of these structures. You can see by this graph that about 75% of those are bridges and 25% are qualifying culverts. And then if we take a look at how many of those structures are on the national highway system versus non-national highway system, about 60% of our structures are on the NHS. And we care about that because FHWA cares about that, and that's kind of how they look at our performance measures. For the folks that are from Colorado, you've seen this graph a lot. We've spent a lot of time in my time at CDOT really focusing on this graph. And this shows the percentage of good, fair, and poor deck area in Colorado, both historical and projected using our Dayton model. Now, what's concerning to us about this graph is you can see in around 2019, our percentage of fair deck area began to outweigh our percentage of good deck area. And over the past couple of years, that's trended up fairly rapidly. And this is concerning to us because it's more expensive to maintain a fair bridge in fair condition than it is to maintain a good bridge in good condition. And given existing funding levels, which you can see at the bottom of the slide here, we're kind of leveling off on our funding as far as preservation is concerned. We also have the Bridge Enterprise program at CDOT, but what they do is they're a bonded state enterprise that takes care of our poor structures. So you can see that they were established around 2009 because our percentage of poor deck area was beginning to creep up on 10%, and we don't want that to happen because FHWA can come step in and tell us how to spend our money. So they did a great job of bringing that metric down, right? They were really focusing on that, but what we've noticed is we kind of lost focus on maintaining our good bridges in good condition. What we've been doing is kind of trying to look at this and figure out, why this is happening. Obviously, funding levels, we would like to see those higher. We think there's a little bit a loss of focus on bridge preservation. But one of the other things that we're battling is just an aging infrastructure. Over 43% of our bridges are over 50 years old, and the design life for these older structures is 50 years. So these structures are, we're forcing them to live past their intended life. And as they get older, as we all know, it takes more money to maintain them in a safe condition. So that's just something that we're going to have to battle. Now, in addition to the condition metrics, the good and the poor, we also track a host of other metrics for our bridges. So we have preservation treatment metrics and risk mitigation metrics, things like scour, load restriction, vertical height restriction. But what I'd like to focus on is the preservation treatments, or as we like to refer to them as our lead metrics. So these are percentage of leaking expansion joints by linear feet across the state, and percentage of unsealed deck area. And the idea with these is that if you're meeting your targets for your lead metrics, then you would expect to be able to meet your targets for your lag metrics or your condition metrics. And this is just a great example photo of what that means to us. So in this photo, you can see that the joint up top started leaking down onto the superstructure, down onto that pier cap. If we had gone in and replaced that joint in a more timely manner, it would have been a relatively inexpensive cost. Versus now to go in and actually repair this structure, we're looking at a lot more funding that needs to go to that to actually get it back up into good condition. So that's one of the reasons why we care so much about expansion joints. The other lead metric that we track is percent of unsealed deck area. So I really like the graph in the top the left-hand corner, illustrates, the importance of that cyclical preventative maintenance. So what this is showing is that if you were to just leave a deck and not touch it for 35 years, and not touch it, and then come in and replace it, and do that a couple of times over the lifespan of the structure, we would expect to expend about 75% of the cost to replace the entire structure. Versus if you go in with preventative maintenance and you seal your decks, we would expect that cost at the end of the life of the structure to be closer to 25% of the total replacement cost. So it just illustrates that it's cost effective to get out there more frequently and implement these repairs. In the bottom right-hand corner, we have actually kind of a case study showing the importance of waterproofing membrane. So the structure E17GI, it's in blue on the graph. It has a sealed deck, and you can see that that deck has stayed in good condition over the lifetime. Versus the unsealed deck, it quickly degraded into poor condition, and then we had to invest a lot of money into that structure to bring it back up to good condition. Current project selection process is really driven toward these items, these preventative maintenance items, at least with our preventative maintenance budget. We take a look at the bridge data, we prioritize our structures looking at that data, and what we try to do is, bring good candidates for bridge preservation up to the top of our priority list. So those structures that are in poor condition, we kind of knock them down to the bottom of the list because Bridge Enterprise is kind of managing those structures. We take a look at things like average daily traffic and condition to really target those good and fair structures for deck treatments and joint repairs. Then we send that out to the regions, and the regions take the list, and they're the ones that actually implement the projects, right? So they take a look at what surface treatment projects are coming through and actually bundle those treatments into projects and implement them. Beyond just our typical process, we're trying to look at the data that we have in different ways to determine, what other sources are driving that graph that I initially showed. And so one of the things that we did is we broke down our poor bridges to try to determine, what's causing them to be poor. And what these charts show here is that, over 60% of our bridges are considered poor just because the deck or the superstructure is in poor condition. Now, if we look at the mechanism of deterioration causing our poor bridges, you can see we have three main mechanisms that we're looking at. So concrete deterioration, split timber girders, and fatigue cracks. So we actually have some projects that we're implementing kind of at a larger level to start tackling these issues. We have a Region 1 bridge deck project, so we're taking a look at the bridges in the region that have poor and bad decks. By bad, I mean maintenance is out there a lot, there are a lot of potholes, and trying to come up with a plan and have an organized list so that when and if funding does come through, we can actually get these structures taken care of and make sure that they're a priority. For fatigue cracks, we've actually bought a Stop Crack X gun with bushings, and our inspectors, I don't think they're using them in the field just yet, but so our inspectors can actually implement the repairs on those cracks while they're out in the field. The third project that we're implementing is a statewide timber bridge repair project. I'm going to get into that now. So CDOT owns around 130 timber bridges, and I think it was Chris that mentioned something about this earlier today, that it's also been CDOT's policy that they want to replace these structures. If you take a look at this, over 80% of our structures were built in the 30s, and they're still, most of them, they're in fair and good condition. And on top of that, if we were to actually go out and replace all of these structures, we estimate it would cost over $290 million. That's pre-COVID estimations as well, which we don't have that kind of money sitting around. Now, the main issue with these timber structures, like I mentioned before, are split timber girders. So you never want to see daylight through your superstructure. You don't want to see plants growing out of that. So this is a real issue, and it leads to a lot of ramifications, right? So once over 25% of the girders on one of our timber bridges become split, we automatically downgrade that superstructure to poor condition. The structure is then re-rated, and oftentimes that leads to load restrictions on the structure, which impacts our freight network. And then the other thing that we see with these is this repeat maintenance that has to take place. Because what happens is that once a single girder splits, it becomes weaker. It starts sharing the load with the adjacent girders, and we see kind of a progressive failure. And that weakening of the superstructure also leads to what you see in these pictures here, this alligator cracking and deck breakup. So there's just a lot of maintenance that has to go into these structures. Now, every time one of our inspectors goes out and they find a split timber girder, they issue an essential repair finding. And with our essential repair findings, they're color-coded for maintenance. This graph at the top here shows that, we've seen an increasing trend in essential repair findings for split timber girders over the years, and most of those have been coded as yellow, which means that they need to be repaired within 90 days. And so what that means is that our maintenance crews have to drop what they're doing and drive out to oftentimes a very remote location to repair these structures. And additionally, what we see with that kind of progressive failure on these timber girders is that they're making repeat visits to the same structures. So the graph in the bottom right shows, we have 18 structures that have only been visited one time for this particular essential repair finding type, but we have one structure that maintenance has had to go out to 8 different times to repair split timber girders. So that tells us that our repair really isn't working. And if we monetize that, we estimate that they're spending over $200,000 a year on these timber structures across the state between those repairs, the deck repairs. They're doing additional inspections because of the problems with these structures. And, that doesn't take into account everything. That doesn't take into account the time lost, and it's really just what we have in our system. So we expect that that is actually a much higher value than what we've been able to calculate. So our current repair is just lag bolts, 18 inches on center. And as I mentioned, we're finding that this repair doesn't provide enough strength and stiffness to really prevent that progressive failure. We issued a challenge to our designers to come up with basically a new specification to repair our timber girders. We wanted to reduce that percentage of poor deck area, open up our freight networks, eliminate all of that repeat maintenance on our structures. And we wanted this to repair to be low cost, something that our maintenance guys could go out and implement similar to the lag bolt repair. We wanted it to be adaptable and able for use by local agencies as well. So we had a really good opportunity, I'll call it, open up. This structure is in the northeast corner of Colorado, and it's, developed 25% split timber girders, was re-rated. So our freight office calls us up and says, hey, what are you doing about this structure? We're having to reroute. I'm getting calls from farmers' wives that we're going to kill their husbands. Can you guys get this fixed? We use this as our pilot bridge for coming up with a new repair. Because it's a 3-span, simply supported structure, we were able to implement 3 different repairs on the structure. So in span 1, we used FRP wrap. Span 2, we used steel sister beam. And span 3, it was kind of a different take on our current lag repair, just using inclined lag screws. Now, some lessons learned for FRP repair. We initially tried to epoxy inject some of the splits, but what we found is that the splits actually weren't large enough on this structure for epoxy to actually get in there and work. So I think we only epoxied 1 girder, and that doesn't give us a very good data point going forward, but it does tell us that it's probably not something our maintenance crews are going to be able to implement in the future. Our guys were real champions. It was a little bit outside of their wheelhouse, but they really stepped up to the plate and were totally open to implementing these new ideas, and they struggled with this FRP wrap. We made the mistake of not buying pre-cut strips, so they were actually cutting the strips out into the field, and they weren't entirely familiar with FRP, so they found, that it was very messy and just very difficult to implement in the field. They spent 2 weeks doing 3 girders until we finally said, you know what, this obviously isn't going to work at a statewide level. Good lesson learned. Now we know. We may be able to try something different in the future, but let's move on to something else. The steel sister beam repair, it's not entirely different or flashy, but it's effective, right? We can calculate the added strength to the structure. With the proper equipment, the guys are actually able to hoist these beams in place fairly quickly, and so that was a pretty straightforward repair. The inclined lag repair was also pretty straightforward. However, cost of that repair was pretty outrageous due to all of the fabrication details on these. You can see that the angles are welded to a plate to kind of help guide that lag at a 45-degree angle. So if we look at total costs, span 2 was the sister beam design, span 1 was the FRP, and span 3 was the inclined lag repair. And you can see that in span 1, labor ended up really driving the total cost of that repair, versus in span 3, the materials really drove the cost of that. What we've decided to do is actually move forward at a statewide level with the sister beam repair. Like I said, we can calculate its benefits to the structures. The guys can implement it. In fact, they've already completed 2 different pilot structures in areas around the state, so they're working on getting that implemented. But, you know, in the meantime, we're still looking into that inclined lag repair and working with a research group to actually determine the added value to the structure and the increased strength and stiffness that that repair provides, in case we can use it on structures that have low clearance or otherwise it's just difficult to get those steel beams in. So with that, does anyone have any questions? I don't know off the top of my head. I would have to look into that. I don't know. Mike, do you know anything different on that one? They are stopping traffic on the structure, but the beams are cambered a 1/4 inch, and so they're just wedging them in as tight as they can with shim plates. So they're not actually jacking the deck. I'm glad you pointed that out because I didn't touch on that. So, you know, one thing about these bridges that were built in the 30s, and I think someone mentioned it today about old timber, some of these girders are still in good condition. And so there's opportunity for when we do have those replacement projects, we do have the money for that and it comes through, that we can go ahead and save some of those good timber girders and use them in the same manner that we're using this steel. So that specifically was all for split girders. I couldn't tell you if more than one of those visits was for the same girder, but definitely not all of them. So I would expect that there are several split girders on that structure that they've had to go out to repeatedly. The question was, with the additional weight of the steel beams, is there a concern to the substructure at that point? Yeah, so what we're finding is, you know, if the substructure is in good condition, we're not really too worried about it. But if the substructure isn't in as great condition, one, they might not be a good candidate for this repair, for us to invest this kind of money and time in. But 2, we just need to take a deeper look at that to make sure.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.